Welcome to our deep dive into Python's system-defined data types, often known as primitive data types. Python, a language celebrated for its simplicity and readability, breaks away from the traditional primitive type mold found in other programming languages. Here, everything is an object, including the foundational data types. This unique approach provides unmatched flexibility in data manipulation. Let's embark on a comprehensive journey through Python's core data types. First up, we have the numeric types. Immutable in nature, these types are the backbone for representing numbers. Integers, int. These are your whole numbers, ranging from the negatives to positives, with no limit on size, bound only by your system's memory. Think of numbers like 5, -3, or 42. Floating point numbers, float, for those times you need precision with decimal points. Python's float is akin to a double in C or Java, allowing for numbers like 3.14 or -0.001. Complex numbers. When you step into the realm of real and imaginary numbers, complex types have you covered with notations like 3 plus 5j. Next, the Boolean type, bool, a simple yet powerful type representing truth values, true or false, guiding the flow of your Python programs. Diving into sequence types, these are your ordered collections. Strings, str, immutable sequences of Unicode characters, perfect for text. Whether it's hello or Python, strings are a staple in data handling. Lists, list. If you seek mutability and versatility, lists are your go-to, capable of housing a mix of data types in one ordered sequence. Tuples, tuple, similar to lists in structure, but immutable, providing a reliable, unchangeable sequence of elements. For when key value pairs are essential, the mapping type steps in. Dictionaries, dict, mutable mappings that connect unique, immutable keys to their corresponding values. They're indispensable for structured data storage and retrieval. And let's not forget about set types, the champions of uniqueness. Sets, set, mutable collections designed to store unique elements, automatically removing duplicates. Frozen sets, frozen set, the immutable counterpart to sets, offering a fixed collection of unique elements. A few additional notes to keep in mind. Mutability. This characteristic defines whether a data type can be altered post-creation. Lists and dictionaries are mutable, while strings and tuples are not. Type conversion. Python empowers you with the ability to explicitly convert types, also known as typecasting, ensuring flexibility across your data manipulation tasks. Dynamic typing. The need to declare variable types up front is eliminated thanks to Python's dynamic typing, where types are inferred at runtime, simplifying the coding process. In conclusion, Python's approach to data types, treating everything as an object, not only enriches its flexibility, but also aligns perfectly with its object-oriented foundation, easing the learning curve and enhancing expressiveness. Whether you're a seasoned programmer or just starting out, understanding these fundamental building blocks is key to mastering Python.